Hi, my name is Hunter Paris, and it's my third day being a blockchain developer. Now, I have been a developer for 20 years, but I am a total blockchain noob. I don't know all that much about how blockchains are built um, and how to code on them or anything. So I've done some of these tutorials here at Substrate. And by the way, we're talking about the Polkadot blockchain network or blockchain chain or chain or network. Um, and Substrate is this framework to build apps and chains and interact with the Polkadot main chain, or they also call it a relay chain. Um, so I've done some of these tutorials. I created the first Substrate chain. I added pallets. Um, I built a proof of existence decentralized app, which takes a file, gets its a hash, which proves that you have it without having to upload that file to the network. And we are going to do the start a private network with Substrate. Now, I've read this tutorial a few times, and I don't actually understand why we're doing this, what the purpose of this is. It really isn't covered here. But the reason that I'm still doing a video on this is because this particular private network is a necessary component for a future tutorial, which is the how to register and interact with your own parachain. So I sort of understand that. Let me just bring up Polkadot network. And let's see if we have a technology graph. Yes. So, oh, this is a great graph here. So the relay chain is the main heart of Polkadot. It's responsible for the network's shared security, consensus, and cross-chain interoperability. This is a great page. Parachains are sovereign blockchains that can have their own tokens and optimize their functionality for specific use cases. So think of it like a company that sells NFTs or that creates NFTs on the Polkadot network. They're going to do a parachain. I'm pretty darn sure. Then there's parathreads, similar as to parachains, but it's more a pay-as-you-go model, more economical for blockchains that don't need continuous connectivity. There are bridges that allow parachains and parathreads to communicate with external networks. Yeah, that's advanced stuff. So there's all these cool consensus rules. That's not the topic of this video. Let's see if there's any talk of network. No. Let's see what this light paper is all about. It's probably... So it's still not clear what the difference between a network and a parachain is. Let's see if the white paper has anything on this, and then we'll try the wiki. Let's see, network. No, this looks way too dense for me. Let's see the wiki. This is feeling promising. Let's see if there's anything on private network. Oh, here we go. Here we go. Okay, so finally, besides running a private network, Polkadot has two other networks where you could test infrastructure prior to deploying. One is a Kusama Canary network. One is the West End testnet. Okay, so this gives us a little bit of information. So I think this term network is kind of used interchangeably. So I think it's either a blockchain or a parachain. That is not clear, but let's not make that the whole purpose of this video. Like, we know it's a prerequisite for one of the next steps, and we learned a little bit from the wiki. So Alice and Bob start blockchain. Alice starts first. Did I skip a step? No. Alice starts first. Alice should run these commands from the node template repository root. So that would have been set up in another step, and you can go check the link in the description for the tutorial page, which you can do the first tutorial step to get this. So let us go into Substrate node template. And I'm going to copy that. I'm going to go, that wasn't good. It copied the comments. So this is going to purge any chain data from previous runs. Sure. All of this has been test stuff so far. Yes. So testnet.db didn't exist, so should be fine. And then we're going to start the node with this giant thing. Boom. Looking good. Let's look at these flags in detail. Okay. Base path specifies directory where it should store all of its data. Chain local specifies which chain specification to use. There was a few so this is more interesting, prepackaged options. Local development and staging. Generally, one specifies their own chain spec file. Cool. But not me. I like to use pre-canned stuff as much as possible. Alice puts the predefined Alice keys, both for block production and finalization, in the node's key store. Generally, one should generate their own keys and insert them. We will generate in a later step. This flag also makes Alice a validator. Oh, so there's a hint. There's a hint. Because if we go back to the Polkadot thing, we know that one of the roles is a validator. So it helps validating. So that gives me a hint that it's probably a parachain. And it's just running privately. So just check Discord to see if anyone's answered my question. Nope. Port, yeah, it says the port. I realize I'm skipping that over for real noobs. It's the port that it listens on. WS port. It specifies the port for WebSocket traffic. Okay, so there's three different ports. I don't really know why, but I don't need to at this moment. The ed secret key. Right, so it just specifies the key. So here's a warning. Secrets provided as command line are easily exposed. Use of this option to be limited to development and testing. Yeah. Right, so you want to store your secret in a file so that, like, if you're on, like, not a public server, but like a shared server, or, you know, good security practices. Tells the node to send telemetry data to this one. Hosted by parity and available for anyone to use. So the telemetry is that website that shows, I'm pretty sure this is maybe telemetry data, but it's data related to the network or to that particular node. Validator means that we want to participate in block production and finalization, right? AKA we want to be a validator node. So when your node starts, you see output similar to that. Yeah, I saw, yeah. Error, but it went away after a while, so we're fine. Notes. Initializing Genesis block tells which Genesis block the node is using. When your start node, verify that these values are equal. Okay. Let's look for this Genesis block thing. There it is. The Genesis block thing. Initializing Genesis block state and header hash. Tells. Well, they're not equal, but they're also not equal here in the notes. So I am kind of skeptical about that. Local node identity is something. Shows the peer ID. You'll notice no blocks are being produced yet. Correct. Blocks will start being produced once another node joins the network. Cool. So that kind of gives me a. I don't know anything about blockchain, so like when you're, what's the sound of one node noding? Well, the sound is no blocks, aka that. But when there's a network, then there's a chain of blocks. Very nice. Very nice. You'll notice some more details. Okay, so now we're going to attach UI. You could tell a lot about your node by watching that. So navigate to there. Handy. Let's see what happens. Okay. Some ad blockers. Getting any ad blocker notices? No. The link. Click the top left and ensure the custom endpoint is sent to 127.9945. Yep. To connect a custom node import, you just need to specify the endpoint by choosing custom endpoint. You should now. But it was set to that anyway. So, yeah. So now we see, yes, we see this. Okay, so here's what we're going to do to set up Bob. Open up a new shell. And copy that one. Substrate node template. So we're going into the same thing, right? And we're going to run this thing on the same code to run the Bob chain. Sure. Correct. Copy this one. This one doesn't have comments, so the paste should work. The paste is working. And now we see in this other terminal, you see, now things are happening. Ooh, I have a self-contained local blockchain happening here. Very cool. Let's see if our thing here, yeah, blocks are being produced. Very cool. Very cool. Most of these options are already explained above, but there are a few points worth mentioning. Because these two nodes are running on the same physical machine, Bob must specify different, all that stuff. Yep. Bob has added the boot nodes flag. So this is flag unspecified, a single boot node, namely Alice's. He must correctly specify these three pieces of information, which Alice can supply for him. So I would imagine that in a real-world situation, the kind of boot node would be like the main Polkadot server instead of my own thing. So, yeah, I'm seeing that. I'm seeing good stuff. I'm seeing peers, right? There it is, peers. I'm seeing peers. So, looking good. Once you verify both nodes are running expected, you should shut them down. So we're going to, we're going to generate our own keys. So this is, so now that we know the fundamentals and command line options, it's time to generate our own keys rather than use the well-known Alice and Bob keys. Each person who wants to participate in the blockchain should generate their own keys, right? Makes sense. You wouldn't want to like use the default password of 123456 that everyone knows when joining a public network. This page explains several options for generating keys. Regardless of which option you choose, be sure to record all the output from the section as you will need it later. Well, this is going to be interesting because I'm doing a video. but this is only going to be used locally, so it really shouldn't matter. And I will never publicly use these, so it should be fine for the purposes of this video. So, let us see. Subkey is a tool that generates keys specifically designed to be used with Substrate. Begin by compiling and installing the utility. Oh, yeah, I don't think I've done that. Like, right? Subkey. Nope. Locate subkey. Yeah, I haven't done it. So we're going to have to do that. Subkey is a thing, crypto hashes, so we're going to do that. And just in case, gosh darn it. My double, I thought I fixed that. Oh, I didn't fix it. I checked out what it was. Sorry, it's 20 years of habit. Information you didn't really need to know. So yeah, we're going to go here, and now we're going to do that. Cool. By the way, I'm not running the M1 Mac. I'm running a very beefy but still old 2016, which is not terrible, but in the world of blockchain, having a good computer is good, or you don't need to have a great local computer. You could just like rent one on Amazon that has enough horsepower for you. So let's see how long this is going to take. Okay, feeling something happened there. Things are moving along, and let's just stop the video. Well, they said it'll only take about 15 minutes, but I will save you all of this time. All right, and literally like 20 seconds after it did that. So run source that, update the environment, boom. And now install only subkey at a specific version. Let's see how long this one takes. And let's look at the logs. Get random. These are all libraries that are needed to build it. Oh, it's a 704. Yeah, I'm going to stop this. And see ya in a instant. And we're back. The key thing has compiled or downloaded from Cargo and installed. So I think we're good. Let's just check that it's actually in our path. No. But let's try doing that. And then no. So we need to put it in our path. I'm just curious what and let's make it bigger so you can actually see. I want to see what we're actually sourcing. Yeah, we are sourcing cargo bin. So it should have worked, but maybe that's for bash. Anyway. So let's go into users hunter p subkey .cargo bin. And before we do that, we'll use this old push D, which pushes it onto a stack. So yes, there is subkey. Okay. So now let's echo our path. Okay, so most likely I am not that good at if path. I don't know. All we know is that it didn't work. So, and Mac uses this ZSH RC now, which I not so good at. So that should be fine. And now we source that. And now there's subkey. Okay. So good. And now you learned a thing, push D and pop D, and what paths are, if you didn't know what those are. So now let's do one of these. Boom. And into demo.sr25519. sr25519. So, boom. So, only using this as a demo. Now see the key and address the same mnemonic. This key will be used by Grandpa. Huh? I'm not understanding this step. I guess you're just supposed to see that if you do inspect with these keywords, it pumps out those keys. For Polkadot.js apps, option 3, use pre-generated keys. No, we made our own key. Now we're going to create a custom chain spec. So now that each participant has their own keys generated, wait. We only did one key. Oh, we will need to generate at least 2 keys from each type. Okay, so into demo2.sr sr25519. And yeah. So now we have 2 keys, creating a custom chain spec. Now that each participant has their own keys generated, you're ready to create a custom chain specification. We'll use custom chain spec instead of built-in local spec that we used previously. In this example, we'll create a 2-node network, but the process generalizes to more nodes in a straightforward manner, creating a chain specification. Last time we used chain local, which is a predefined chain spec that has Alice and Bob specified as validators, along with many other useful defaults. Rather than writing our own chain spec completely from scratch, we'll just make a few modifications to the one we used before. To start, we need to export the chain spec to a file called bat. So copy that thing. I don't think it's going to work here, no. So we need to go to Substrate, node template, and then do that. So it built a chain spec. How long is it? Oh yeah, 210K. File we just created contains several fields. You can learn exploring them by the largest field is a blob. That's why it's 200K. The portion we're interested in is the Aura authorities thing, indicated by the Aura field and grandpa authority. Okay, so let's just use VI. Interesting. I am not seeing this. There it is, way below the blob. Way below the blob. There's the grandpa. So yeah, there's 2 keys. One for palette and one for grandpa, although it's done in a slightly different syntax. Format for grandpa is more complex because weighted nodes, each validator has a weight of 1. All we need to do is change the authority. Okay, so now the question is which thing do we put in there? I assume one of those things from before. This is where we want definitely a new that, although I think we have one. Let's look at demo dot. Yes, so let's read about which key we need. Addresses. SS58 address. Change the authority. So for additional context, read keys in Substrate. SR, yeah, address format is a simple address format designed for blockchain. We say there's no problem with using other address formats, but this serves as a robust default. It's heavily based on something. Yeah, so this is what we want as the SS58, which is also happens to be the same as the public key. So interesting how they have 2 different authorities. What's the difference between the 2? What's the difference between the 2? Maybe it gives a hint. All we need to do is change the authority addresses listed to our own addresses. The SR go in the Aura section and the ED. Wait a minute. Oh, no. I know I didn't do that right. I know I generated 2 of the same. And look, What threw me off is they're both 2259, but one's an SR, one's an ED. So we are going to have to do that again. Sadly, we have to get out of this, go back one, see our history. SR 2259. We need to generate at least 2 keys from each type. Oh. Okay. Well, they did say 2 keys for each type. And there are 2 keys there. Let's just look at these 2 provided demo keys. I see public key and address. So that's, but if we look here, at demo, we see that the public key, okay. One is in hex form, one is in address form. But here they're both in one of those forms. Weird. But it did say 2 keys. Wait. They provided the 2 keys, so let's compare the 2 keys. Crack it open to another window. Do it like so. Wait, didn't I just do it? Oh, it reabsorbed it. So, boom. And now to here. Okay, so that's that, and this is this. Okay. So we see 5Z. And then here's 5G. Oh, wait a minute. Pair 2, pair 1. Okay. Yes. So we need to generate 4 keys. Isn't that fantastic? Okay. That's a lot of keys. Okay, so now I get it. So we actually didn't do too much. We didn't do unnecessary work. So we want a ed into demo1.ed, and let's cat demo1.ed. Okay, looks like something, and then ed into demo2.ed, and I need a glass of water. Okay. So now we have a whole bunch of keys, and we need to input them. So let's cat demo star. Boom, nice and easy. Open up another window. Open this up, cd to Substrate node template. Now we're going to edit that thing that we made, custom spec, grandpa. And now we need a third window open so that we understand, again, which goes where. This can go back there. Actually, we don't even need that window anymore, and all these other ones either. So the SR goes into Aura, the ED goes into Grandpa, and they seem to be using that format. So here's an Aura one. So open up that. Okay, so I need to look at this again. Let's just do this one at a time. Okay. We're in Aura. Aura is 22. Aura is SR. So we need the SRs. And since we don't have file names here, that's not going to work. So let's do a reset. There is a fancy shell command, but let's just do cat demo1. No, we want SRs. Demo1.sr. What? Demo.sr and then cat demo2. Oh, see, I was inconsistent in my naming structure, but that doesn't surprise you. Now, does it? Given what you've seen of me already. So we want this thing public key, and this is going to go into Aura. So boom, boom, comma, dot, 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 and then this one goes into there, there. Very nice. And then this has a slightly different structure. I think that was a weight. So now we want the process of elimination. Yeah, and cat demo2.ed. Okay, so okay, need a comma, and they look separate, they look different, comma. That should be it. Okay. Well, that was a process and a half. Once the chain, convert it to a raw chain spec. Okay. So, seemed like it worked. And there is our custom spec raw. Let's take a look at it. Who knows what the difference is? I know I read it before somewhere. Finally, share with my other validators on the network. A critical note, single person should create a chain spec and share the resulting chain spec with their fellow validators. Because Rust optimizers aren't reproducible, each person will get a slightly different WASM blob, which will break consensus. Okay, if each participant generates the file themselves. Okay, so there's a blog post, but too long, didn't read blog post is share it. So boom, and then well, we just changed our chain spec, so okay. Looks cool. That's the first node. And here are some differences from when it launched Alice. I've omitted the Alice flag. Instead, we will insert our own custom keys into the key store through the RPC shortly. Idle. The chain flag has changed to use our custom chain spec. I've added the optional name flag. You can give it a human readable name, and the name is mynode01. The optional RPC unsafe, I don't like the sound of that, method has been added. As the name indicates, this flag is not safe to use in production setting, but it allows this tutorial to stay focused on the topic at hand. Okay, cool. I should see output like that. Here you must take the note of the node identity, the IP address port. These values are, for this specific example, they will be required for our nodes to directly connect with. So am I running off 127? I am. Probably 1999.45, which is different from that. Okay, so and now we're going to add keys to the key stores. I definitely want to use this thing. and I don't have the URL. But it was, oh, that's annoying. I closed that window. That JS thing was given, I think in this step, yeah. This is something I'm going to want to save in my Polkadot thing. That is something I'm going to want to save. So option 1, use the Polkadot.js apps UI. You can use the apps UI to insert your keys into the key store, navigate to developer RPC call, choose author and insert key. Navigate to developer RPC calls. Choose, didn't they say developer? It said what? Choose author, and insert key. Okay? Fields can be filled like this. I have to do this 4 times? Oh my good. Oh, there's an, yeah, this seems manual. The only question is I have 4 files. So I'm not clear on that. Okay, so like 15 minutes has passed, and I've kind of figured out what's going on here because the docs confused me. So let's, right, you start your node. Now we have to add our keys to the key store. So what confused me is that we've generated 4 keys, and it wasn't clear to me. Don't worry, I'm showing you what was confusing me. It wasn't clear to me. And actually this could be an improvement, which should be, you know, some kind of explicit thing here, like node 1, node 2. I assume that there's some kind of sequential ordering going on, you know, like this one is paired with this one, and this one is paired with this one. I mean, it would have to be something like that. So let's now, with that assumption, which is the only thing it could be, let's go back and try this again. So the first thing we're going to do, we've started, just a refresher, we've started just one node at this point. We're going to insert an aura, aka a 2259 key, and that's going to be the first one here. And there are some other fields which we need to go get. So we need to say it's an aura. So we need that thing, and then we need the hex thing. So let's keep this window open because this is why explicit is so much better than implicit. And so we're just going to get all 4 of them here. So we have a mapping. Oh my gosh, and that thing at the top is bugging the crap out of me. Boom. Demo 2, cat, demo 1, then cat, demo 1, demo 2. Oh, I messed up my pretty. Oh, sorry, guys. Oh. Ed. There we go. Okay. So now we have all these here. Okay, so the first key we're looking for, and wow, is this process not efficient, but I'm sure if you're doing this day in and day out, you'll have a process set up. So first thing we're looking for is a ending with J5RR2. And that would be the first one. It's an SR. Yeah, SR corresponds to Aura. I would rename these now that I understand a little bit more what's going on. So the first thing we need is to say Aura, and then we need our phrase in the first one. And now I'm regretting, but it's okay. And the next one is the public key in hex format. Okay. And let's go ahead and fast forward through this now. So now we're going to insert our grandpa key. So grandpa, and grandpa is Ed. So I assume do it like so. And we get our hex like so. Submit. Oh no, bad key type. Huh? Did I do something wrong? Oh, I'm just supposed to type gran. Cool. Not an error. Okay. So yeah, let's verify keys because I am so unconfident about this process. Oh no, what did I do? Okay. Yay! Stuff. That doesn't correspond to anything. And so, let's see this. Oh no! Oh, I see, I see. We're supposed to insert the string that we got from step 1. Okay. And I'll believe step 2 worked. Now subsequent participants. So before we do that whole key rigmarole, now that we have the process down, the second time should be faster. So we're going to go here. We're going to go that. Fine. I have to fill the correct info in the line above. So and I'm going to go to our other running node, go to the top of it. How do we know we're correct? And my head is cold. Actually, my body is cold. I'm going through that hot flash, cold flash part of the evening. You may think I'm extra weird, but I'm just trying to not make it seem weird when I do this about 5 times. So let's just verify. If you didn't set the correct node ID gathered from another running with the same chain spec, but only the right IP, will get errors. Okay, so you must fill in the correct info in the line above. Boot nodes, IP address, yeah. TCP/ peer-to-peer port, and a peer ID. So let's just see. The other one is 3333. Yeah, so we're going. Yeah, so we're running on 127. The peer-to-peer port is 30 something. The peer ID is what we need to get correct. Well, I assume it's that. So then the only thing we should need to change is that. So let's give it a go. Yeah. Go to the bottom of this. Yeah. Blocks are happening. Oh no, it says idle. Oh no, idle. Oh, but it says it has a peer. Yeah, so before it was at 0 peers. Yeah, we're importing blocks. I think we're working. If I didn't set it, I would see the boot node, yeah, provide a different PRD than the one you expect. So I didn't see that. So yeah, I'm pretty sure we're working. As before, we specified base path. Now you must set the authoring keys in this node just before we did for the first node. This can only happen if more have added their grandpa keys to the key stores. Well, I didn't do that. I should see both nodes report. So this is actually important. I really want to skip over this, but I know it's important. The final lines show you that your node has been peered with another peer. Okay, so this is really important. But as before, block production. Now you must also set the authoring keys in this node, just as we did for the first node. Right, I didn't do that. Note that you'll need to communicate with your node on the correct WS port. So setting the app UI into... Okay, so we go to our UI here, and I'm pretty sure 9945 was the first one. So, and I'm pretty sure 9946 is the second one. So custom endpoint 9946, hit enter. I guess we'll hit switch. I'm just looking. I just assume that because the UI refreshed, we're good. Let's go to Explorer. Node info is what we want. Who are we, though, is the question. Chain state. Extrinsics. Let's try the system call. Oh boy, I'm scared. I don't know what I'm doing. Let's back off from that. But $99.46. I hit enter, nothing happens. I just guess it's because like I hit X and I come back here. I guess that means we're on 99.46. There's probably another more explicit way to find out. Chain state. Constants, extrinsics, settings. No, we don't need settings. So we're connected to 3Q. Wow, is this annoying? I'm trying to look at the top of my terminal here. Right, okay, finally found it. So we specified that the node that we're connecting to is 3Q, and the connected peer here is 3Q. So let's just go to 9945, hit switch. Yeah, and now we see connected peer is FV. So yeah. Let's go back to 9946. Switch. It's probably a faster way to do that, but I don't know how. Anyway, now I got a good little bit of confidence that my little verification exercise there provided me with. So, boom. So now we have to do our keys for this one. So, let's go back here to our key thing. So yeah, the first one is Aura, the second one is Grandpa. So the first thing we're going to do is copy that, and then I don't remember. I think it was RPC calls. Yeah, RPC calls. I think it was author, and I think this thing was insert key. Yeah. So key type is Aura. I have that. And now the public key in hex form. Boom, submit it. Excellent. And now for number 2. We're doing a gran. We're doing a this. And public key. Use that. Submit it. Boom. Okay. So, this can only happen if more than 2/3 have added their grandpa key. So, yeah. Since the network was configured with 2, can occur because, yes, 100%. All that, yeah, we're doing that on the second node is running, and it has author key. You should see both nodes reporting block authoring. So I didn't really check if they weren't doing that before, but I guess we can see, yeah, so there's a whole bunch of idleage there, but that was probably from before I started the node. Yeah. I think we're good. Yeah, I think we're good. Feels like we're good. I guess we're going to read some logs just so we understand kind of what's happening. Is this easy? No. Could there be better tools for this? Yes. Is knowing how to do it useful? Yes. Looking for block authoring. So I guess prepared block is what we're looking for. So prepared block. Oh, yes. Oh, I see. The gift thing. So we're looking for the gift emoji. Yeah, we're seeing prepared block for proposing at 55. And or 54, 56, 55. Fantastic. Seems good. Final line shows you notice appeared. And we already confirmed that through my other exercise. But do notice that even after you add the grandpa key second node, substrate nodes require a restart. Kill your nodes. Now my blocks should be finalized. But do notice that even after you add the grandpa key for the second node, no block finalization has happened. So let's look for that. Let's look. Is there an emoji for finalization? Is there an emoji for finalization? It's under the ZZZ and the idle. So finalized there. ZZZ idle finalized there. Well, that's not adding up. But I believe it. Let's just quit them. Boom. Boom. See what's happening. I mean, we were getting finalization before, so maybe things have changed. Maybe things aren't working, but I don't see any errors, and blocks are both being produced from both. So I would say we're finished. So fantastic. Wow, that was quite an ordeal. But now we've done our own private network. And starting this whole thing off, I think we have yet another answer to our question because of this kind of thing. So there's West End parachains. Ooh, there's a whole list. That's interesting. There's Rococo parachains. There's Kusama. Whole bunch there. And then there's, oh, look how clean that is. Polka dot, just polka dot. I wonder what happened. No, if I click there, I'm scared to click there. So development, there's a whole bunch of test networks. Then there's live networks. So there's a whole bunch of stuff going on here. Okay. Still don't understand the difference between a private test network and the other stuff that we did in the previous tutorials was, but I feel like we did learn a lot of things here, but I still have a lot more questions. The more you learn, the more questions you have. So check the description below for the link to this tutorial. And I guess subscribe and give me a thumbs up if you made it this far. So, and by all means, like, shoot me some questions. You know, I'm just a noob here, just on my third day, but would love to talk to you folks. And just the more blockchain I can talk about, the better that we can talk about. So thank you, and have a great blockchain day.